Hey folks, Dave here. Today we're going to be talking about the scientific method and its implications in AP research. A general overview of the video. We will be focusing on the scientific method. I'll throw in some examples. I will provide a connection to daily life. And the main purpose of the video is for y'all to understand how the scientific method connects to research papers, to independent studies and literature reviews. This is a nice reference slide in case you wanted to come back and look at any points of the scientific method. So the first part of the scientific method is to identify a question or field of interest. This should be based on an observation in the natural world. It is very important that the question is specific and it is testable. Okay, specific and testable. I'm going to give some examples here of questions that I think are pretty good and pretty not so good. So a good question is A good question is, does a loss of function sting mutant impact vesicular trafficking of protein X and cell immunity? Here I'm talking about protein X. You could fill in the blank with whatever protein or protein complex. It doesn't really matter. But essentially what we're asking here is, when we take this loss of function sting, right? So this protein that normally works and normally has a pretty important role in cell immunity, and we basically inactivate it and compare it back to a functional protein, do we see a difference, right? Do we see a difference on vesicular trafficking? So that's one of the specific things that we're looking at. The other is cell immunity. Do we see a change in cell immunity? Are we seeing changes in autophagy, which is part of cell immunity? Maybe we're looking at transcription factors. Is there an upregulation, right, of transcription factors? So these are all things that I can test. These are pretty specific. One question that is not as specific and not as testable is cell immunity good? It's a silly question. But the point of it is, it's not specific and it's not testable. There's nothing I'm testing here, right? It's not as specific where I could say, I'm looking at vesicular trafficking or I'm looking at cell immunity. There's really no meat on this question. Okay. Shifting a bit more to a humanities lens, kind of a family policy or cross-cultural policy lens. How do factors like financial instability and lack of early childhood educational programs impact total fertility in societies? This is a mouthful, but it's specific, it's testable, right? Like, it's specific because financial instability, that's one factor. Early childhood educational programs is another. And its impact on total fertility. Like, I can measure this, it's pretty specific, right? Why don't people have children? I feel like this should be in all caps. This feels like someone's shouting this at you, right? It's biased. It's not specific. It's not super testable. And one thing I will say about this, on the biased, part of the question is, when you are working on an experiment or working on a project, you need to approach it with no expectations, right? If you approach it with the expectation that, hey, my hypothesis is going to be right, or if you're approaching it from a biased lens, like, hey, children good, people should have more of them, right? You're going to create more false positives. And this is a big problem in research and a topic that we could focus more on later. But I just wanted to bring this to your attention so you could start thinking about this. So the background research, looking for background literature on the topic, is pretty time consuming, but is extremely important. Here, you're gathering information about why your field or your field of interest is important, what is known about the topic, what are some questions that scientists are currently thinking about, and can they be resolved by additional research, right? So yes, you will be looking at the gap in knowledge. I don't want you focusing on this at the start, okay? I want you to focus on why is this topic important, then focus on what is known about the topic. This bullet comes a little bit later as you understand more, as you've read more. Then you could say, yeah, this review talks about this problem. This was addressed in this other review, but a commonality is this other problem is something that's not accounted for. And maybe that's something that you can do a bit more digging in. Again, don't spend too much time in the beginning looking at the gap in knowledge. It's not going to help you. You should be looking at the importance of the topic and what is known about the topic. A hypothesis is something that people should be fairly familiar with. It's a prediction or educated and carefully crafted guess based on background information that already exists. You cannot do this before you do background information. Or background research, pardon. You will be looking into patterns. You might be looking into the experimental design of other papers. Maybe, if you were a scientist looking into crafting new experiments, you might base your experiment off of an experiment someone else did. And this brings me to my next point, experimental design and running experiments. You are not actually doing this, okay? You're not actually running experiments in this course. That is not the point of the course. But it is pretty important for you to understand general theory of experimental design and the importance of this step when you're reading papers, okay? Again, not testing anything, you're not creating experiments, but you will be reading about them. So based on the hypotheses that you have made or that the scientist has made, you would, or the scientist would, create a reproducible experiment. Reproducible is very important here. If you can only do this experiment once in a blue moon, right? It's not super helpful. It has to be something that other scientists can do. It has to advance knowledge in the field. If you're testing the same thing, or if you're testing something that is well established, it's not really important. We know about it, And does it create any confounding variables? So if you ever see this word confounding variables, or this term confounding variables, it is referring to things that might be contributing to a phenomenon that you are observing, but are not accounted for. So an example of an experiment with a bad third bullet point that has confounding variables would be if I looked at the hypothalamus, a part of the brain, of three clusters of mice, right? And each cluster of mice has a different sleeping schedule, right? One group goes to bed from 9 p.m. And wakes up at 9 a.m. Another one sleeps between 10 p.m. and 6 a.m. Another one sleeps from 2 p.m. to 5 p.m., right? These inconsistencies add to complexity. When we're creating experiments, when we're designing experiments, we want to reduce complexity. We want to do our best to target one thing at a time. So, just a quick note about that. Oh, one other thing. When you're reading papers, and you will get better at this as you go, if you're looking at figures and you're thinking to yourself, man, there is a lot of confounding variables here, make a note of it. That might be a limitation of their research, maybe something that they could improve upon. Being critical of a research paper is a pretty good idea, especially when you're reading tons of them to point out limitations or critiques in papers. Data analytics, right? You're basically just looking at general trends. Don't worry too much about the p-value. I'll make another video, or I'll mention this at a later point. This is just a measure of statistical significance. How likely is whatever you're testing due to chance, right? Don't worry about it too much. And yes, consider the limitations of the experiment. So, the conclusion. What inferences and interpretations can be made from your experiment and data? Was your hypothesis right or was it wrong? Okay, I'm going to take a second here. I don't care if your hypothesis was wrong or if it was right. Just because a hypothesis is wrong does not mean it's bad, okay? Again, science is complicated. Biology, chemistry, physics, sociology, all these different topics are super messy. There's tons of variability, okay? It's okay if it's not right, because then we could say, oh, this is probably not causing this phenomenon, or not causing, this sort of, aspect of society, right? Don't approach anything in science with expectations that you are right and trying to prove yourself, right? Don't do this. Bad. Very bad. That is not how science works, and that is a big problem in science, and I'm sure that at some point in the course we will address this a bit more. What are some limitations, next steps, any lasting questions? Okay. And finally, publication. You want to share your information with the rest of the world, right? You don't want to just keep it to yourself. Okay, part 2 of the video. Connections to daily life. So imagine you are this cartoon figure, and you're watching TV, and all of a sudden your really important remote stops working, right? Catastrophe. What do you do? So you're going to ask, why is my remote not working? How can I fix it? Valid questions to have in this situation. And you're going to consult the mighty resource of Reddit, and you're going to see if other people are having the same issue, and if they are, what they're saying. Okay. On Reddit, they're saying there's a problem with the batteries, right? So your hypothesis will be, if I change my batteries, then the remote will start working. That's what you're testing. You're going to create an experimental design where you're going to change the batteries in the remote, and you're going to compare the remote with the new batteries to the remote with the old batteries, right? Maybe you're not sure which type of battery, AAA, AA. So one of your experiments could be trying to fit it into the battery port. Then you're going to do some data analysis, right? If I hit the sound volume and I try to increase it, does that actually increase the volume, right? If I hit the on-off button of the TV, does that turn the TV on and off? And then I have my conclusion. The remote must have been fixed if all of the buttons work now with the batteries, right? You publish it on Reddit. You share your thoughts, right? So this is just a silly kind of real life example of the scientific method, and how much we actually use it in our day-to-day life without really thinking about it. Okay, so this is the main purpose of the video. Now that we know what the scientific method is, right? How do we connect it to research papers? Because we talked about this. We're not doing experiments. We will be looking at them. And it's important to understand their thought process, but when it comes to independent studies and literature reviews, what are we really looking at? So first things first, papers use the scientific method to test naturally occurring phenomenon. I mentioned this 5 times in the video. Papers use the scientific method to set up a story or a narrative based on their data. So one thing that you will notice pretty quickly as you read papers is all papers, yes, they have data, but they're trying to tell you a story. They're trying to bring you along with their logic, okay? Why are they testing, one factor in society? Why are they looking at one population of birds? Why are they looking at a protein? Why are they looking at a laser, right? Why? Once they establish that, then they can guide you through all of the experimentation, and then they could try to put it all together and give you a satisfying conclusion. Please be aware. Sometimes, purposefully or not, papers will or authors will try to disregard certain data as unimportant. Keep an eye out for that. If you're looking at a figure, so let's say in biology, you're looking at a figure of a Western blot, and I'll make another video on all these techniques and figure types in biology. But when you're looking at one of those figure types, and they're like, oh, you should see our knockout was perfect, right? So you should technically not see a band. But if I'm looking at the band where that knockout should have been, and I'm seeing, hey, there's some protein there, then it's not perfect. And if their later results are kind of iffy, well, then that might be because they didn't select a good knockout. So be critical, okay? Also, the last aspect, right? Your publication. Scientists read up on topics and then they share their results, right? That's how data is shared. That's how information is shared. Back in the day of Galileo Galilei, people kept all this information to themselves, right? It is very important to carefully document your experimentation and your scientific thinking and share it with the world. So one, people can actually critique you, and two, so that we can all increase our knowledge of natural phenomenons, right? Or natural phenomena. Okay, this is the end of the video. I'll try to make more helpful videos talking about how to read a research paper, how to analyze figures, that sort of stuff. So I will see you in the next video.